Hey guys, I'm Pat Kelly. Okay, this is one of our problems where they give us that generic nth term of the sequence. It's really just a formula, and they want us to find the first 5 terms of the sequence. So we really just use the formula. They do specify to start with an n of 0. So to begin, I'm going to have a sub 0. And I kept calling it a formula because now you just take that subscript and plug it in wherever you see an n. Minus 1 raised to the 0, 0 plus 3 factorial, and then 0 factorial downstairs. And of course simplify. So this equals negative 1 to the 0 is just 1. Multiply. 0 plus 3 is 3. 3 factorial, that's 3 times 2 times 1. That's 6. Division by 0, oh no, actually it's okay. 0 factorial by definition equals 1. And that simplifies to just 6. All right, 1 down, 4 to go. Finding the first 5 terms then of the sequence, you're just going back to that formula each time. This time my n is 1, so minus 1 raised to the 1. Times parentheses 1 plus 3 factorial divided by 1 factorial and simplify. So negative 1 to the 1 power will give me a minus. 1 plus 3, 4 factorial. 4 times 3 times 2 times 1. That's going to give me 24. And even the denominator, I should address it, just 1 factorial, that's 1. So I'm getting a negative 24 for my second term. Okay. Third term, come up here. A sub 2 equals, following my formula, negative 1 raised to the 2 power. Let's go right in and do some arithmetic in our heads if we can. 2 plus 3 is 5 factorial. And divide by my n is 2, so 2 factorial. Let me slow down there, because some people might even shout out right now that you know what 5 factorial is. Maybe some of us don't. I think it's 120, and you can grab a calculator. But I'm going to show you something else, which I'll use for the next few terms as well. When you have a factorial up top and down below, you can simplify and make your arithmetic a little bit easier. So let's continue and try to simplify a little bit. And I'll even do that negative 1 squared. That's just a positive 1. Okay. But it's the factorial that I want to kind of focus on here. And 5 factorial is 5 times 4 times 3 times 2 times 1, which I'm actually going to write as 2 factorial, right? 2 factorial is 2 times 1. But I stopped there and wrote that exclamation point because now the denominator, which is 2 factorial, I'm not going to expand that. I'm actually just going to divide. So those two factorials divide out. I told you it'd be hopefully simpler arithmetic. So this will equal now 1 times 5 times 4 times 3. So what, 20 times 3 looks like 60 for my third term. Fourth term, a sub 3. Still just following my formula. Minus 1, but my n is 3, so minus 1 to the 3. 3 plus 3 is 6 factorial. Divide by 3 factorial. And I'll do the same kind of simplifying trick, as I'll rewrite that 6 factorial up top. Let's first address the minus 1 will give me a negative, right? But then that factorial will be 6 times 5 times 4 times 3, 2, 1, which I'll write as 3 factorial, because I'm looking at how that's going to cross out. It's going to divide out with the 3 factorial that's downstairs, right? And then again, hopefully, simpler arithmetic. This equals, let's see, 6 times 5 is 30, times 4 is 120. I don't want to lose that minus sign, though. Negative 120. Okay, one more. A sub 4 equals minus 1 to the 4th. 4 plus 3 is 7 factorial, divided by 4 factorial. And my next step, do that same factorial simplification. Negative 1 to an even power, though, that's going to be a positive 1. 7 times 6 times 5 times 4, 3, 2, 1. I'll collapse into 4 factorial. So I can leave the denominator as 4 factorial and divide. And then 6 times 5 is 30, times 7 looks like 210. Positive, right? Second half of the directions said to verify your work by using a graphing utility. And that's it, I think. 5 terms, 1, 2, 3, 4, 5. Okay? That's it for this one. Get comfortable with those factorials. I think they're kind of fun to play around with once you get the hang of it. Do some more on your own.